A water skier skis over the ramp at a speed of 30 feet per second. How fast is she rising as she leaves the ramp? Okay, so we have some information given to us in the picture. We know that the ramp is 15 feet long. We know that it's 4 feet tall. We're not sure about the length of the ramp itself. But we're going to try and use all this information to sort of calculate what we do know. So first things I know, I'm given the fact that dz dt, that's the rate as far as I'm going over the ramp itself. The speed here that I'm traveling along this ramp is 30 feet per second. I also know that my y value is 4 feet. Now this is important because really what I'm trying to figure out is the rising. How fast is she rising? That would be this distance. So I really want to know my dy dt. That's really what I'm solving for in this problem. We have to identify that so we know what we're solving for. So in order to do this, I need to know this length. I need to know what z is equal to as well. So how can I find z? Well, we're going to rely on our old Pythagorean theorem that says in a right triangle, x squared plus y squared equals z squared. All right, so now we're going to go ahead and take our derivative. Actually, for right now, we're not going to do that. We're just going to solve for z. We need to find that value. So what do I know about x? I know that x is 15. I know that y is 4. And I know that z is what we're looking for. So I'm going to go ahead and multiply that. 15 squared is 225. 4 squared is 16. And z, we still do not know. When I add those, I get 241. And so how do I get z by itself? Well, we're going to square root. Normally when we square root, we get a plus and a minus over here. But because we're talking about length, that means we would only have a positive version. So that means z would be equal to the square root of 241 feet. Okay, so I now know that. The next piece that I want to focus on is how am I going to get something where in this equation, you'll notice I have an x, a y, and a z. I don't want to have 3 variables. I only want to keep 2 if at all possible. So I'm going to try and get rid of this. I'm going to try and eliminate one of those variables. And I'm going to do that by saying, in my picture, I have this proportion set up that says x is to y as 15 is to 4. X is to y as 15 is to 4. Okay, so I'm going to set that up. X is to y as 15 is to 4. Well, multiply both sides here. I can actually get then that x is equal to 15 over 4 y. So these are pieces that I'm going to now carry forward into creating a new equation. So I'm going to use this idea, because remember when we're talking about these kind of problems with implicits or derivatives, what we normally need is a picture, which we have, and a base formula to go off of, which we're going to use Pythagorean theorem. So here's what I have. X squared plus y squared equals z squared. I'm going to now plug in what I know. So I've got x squared, which we just said was 15 over 4 y. Y squared and z squared. And so here I have 225 over 16 y squared. In order to get a common denominator, I'm going to call this 16 over 16 y squared. And when I go ahead and simplify this out, I'm going to get 241 over 16 y squared equals z squared. Okay, so what we're really looking at then is, can I take the first derivative of this piece right here and try and solve our problem? Now, there are other ways to do this problem. This is just one approach that I think is probably more appealing to most people. So I'm going to take the first derivative with respect to time of 241 over 16 y squared. And I'm going to do the same thing on the other. So I'm going to take the first derivative with respect to time of z squared. And so when I take this first derivative, what I get then is I get the 2 multiplying times this. So I'm going to get 241 over 8y. And because these letters don't match, I get a dy dt. And on this side, I'm going to get 2z. And again, because these don't match, we get a dz dt. So now we're going to go ahead and see if we can start plugging in some values. Plug in what we know. So I have 241 over 8. Do I have a value for y? Yes, they gave it as 4 initially. Do I know dy dt? No. That's what we're solving for. Okay, I have my 2. Do I know my value for z? Yes, that's the square root of 241. And do I know dz dt? Well, if we go back, we said at the very beginning that dz dt was 30 feet per second. And again, if you want to put in units, that's probably better. It's cleaner to do it, but you don't have to as long as you're careful. All right, so now we're going to try and clean this up a little bit. So I'm going to go ahead and move some numbers around. So this is now dy dt. And by dividing by this on both sides, I'm going to have my 2 square root of 241 to 30. This reduced to give me 2, so that means I'm going to have a 2 on the top. I'm going to be dividing by 241. So I'm going to plug all that into a calculator, see if I can come up with some kind of a cleaner answer. And what I come up with is that this is approximately 7.73, and this is feet per second. And so now we know, if we go back, we could say the water skier leaves the ramp at about 7.73 feet per second.